I want to go through how to do the 2017 Particle Motion FRQ. So I'll start by reading the problem, which is two particles move along the x-axis. For 0 is less than or equal to t is less than or equal to 8, the position of particle p at time t is given by position of t equals the natural log of t squared minus 2t plus 10. Well, the velocity of particle q at time t is given by velocity of t equals t squared minus 8t plus 15. Particle q is at position x equals 5 at time t equals 0. So I went ahead and I wrote out the equations and the information we've been given that will help us solve this problem. So let's get started with part A. Part A asks, for 0 is less than or equal to t is less than or equal to 8, when is particle p moving to the left? So we should first start by thinking, how do we know when something is moving to the left? And that's by looking at its velocity. But we're only given particle p's position. So in order to find when particle p is moving to the left, we're going to need to take the derivative of its position to find its velocity. So let's start by doing that. So I'm going to say x prime of p of t equals 2t minus 2 divided by t squared minus 2t plus 10. And so we want to know when something is moving to the left, that means that its velocity is negative. So we need a way to find where between t equals 0 and t equals 8 that our velocity is a negative. So I'm going to start by setting this equal to 0 to find out where the threshold is for where it changes from negative to positive. So I'm going to do a quick check of the bottom to make sure that this quadratic won't equal 0. So if we do the square root of b squared, which is 4 minus 4 times a times c. Okay, so the bottom of our fraction will never equal 0, so I only need to look at when the top equals 0. So 2t minus 2 equals 0. So therefore t equals 1. So now we need to find, since they're asking for a time interval, I'm going to set up a sign chart to see where the velocity is negative. So from 0 to 8 is our time interval, and at t equals 1 we have a 0. So I'm going to quickly plug in these values, and I get that it's negative here and positive here. So particle p is moving left when t is the element of, write that a little neater, when t is the element of 0 to 1. All right, that's part A. Let's move on to part B. Part B asks, for 0 is less than or equal to t is less than or equal to 8, find old times t during which the two particles travel in the same direction. So like I mentioned in the previous problem, in order to know a particle's direction, we need to look at velocity. So we know when they're moving in the same direction, their velocity will have the same sign. So let's look at that. So I'm going to start by making a sign chart for particle p, which we just did above, so I won't go through again. It's 0 to 8, and then 1, and this is negative, and this is positive. So now we need to look at particle q and see where these signs overlap. So the equation for particle q for its velocity is t squared minus 8t plus 15. So if I have t squared minus 8t plus 15 equals 0, then that means t equals 3, and t equals, that means write 3 again, t equals 5. So let's put this on our sign chart. So we have 0 to 8, and then 3 and 5, and this is a parabola that opens up. So that makes our sign chart easy, and it'll be positive, negative, positive. So now what we can do is we can look at where these values overlap, and therefore get our answer of when they're moving in the same direction. So what I see is that the particles move in the same direction when T is the element of, well, let's see. So it'll be, these will both be moving to the right or in the positive direction from 1 to 3, and also from 5 to 8. They'll be moving in the same direction. Okay, moving on to part C. Part C says, find the acceleration of particle Q at time t equals 2. Is the speed of particle Q increasing, decreasing, or neither at time t equals 2? Explain your reasoning. So for particle Q, we're given its velocity, and we know that acceleration is the first time derivative of velocity. So to find the acceleration at time t equals 2, I'm going to take the derivative of velocity. So I could say v prime of t equals 2t minus 8. So then, and this is equal to acceleration, so I'm going to rewrite it as acceleration at time 2 equals negative 4. And the second, so that's our acceleration at time t equals 2. But then it's asking for if the speed of the particle is increasing or decreasing or neither at time t equals 2. So we know that something is speeding up or slowing down when its velocity and acceleration have the same sign. So we need to look at the velocity of the particle then when time equals 2. So the velocity of 2 equals 3. And so we see that this is less than 0 and this is greater than 0. And so therefore the particle is slowing down at t equals 2. And this is because velocity and acceleration have different signs. Okay, so now for part D. Part D asks, find the position of particle Q the first time it changes direction. Well, we know something changes direction when its velocity changes sign. So if we go back up and look at the sign chart we made for particle Q, we can see that the first time it changes sign is at t equals 3. So I'm going to use this in part D. So we need to start by writing an equation for the position of particle Q. So the position of Q of t will equal, well, they gave us its position at 0, so its position at 0 plus then the integral from 0 to, they want the first time it changes direction, so 3 of v of t dt. So if I actually do this integral, I'll get that this equals 5 plus, this would be t cubed over 3 minus 4t squared plus 15t from 0 to 3. And this equals 23.